You get real quiet when it gets too loud. Not because you're shy, not because you're awkward. Your brain is pulling the emergency brake. Three conversations stack on top of each other. Someone laughs too close to your ear. Your mouth just stops working. Here's what's actually happening. Your amygdala did something to your voice. Picture a control room behind your forehead. Wires running everywhere. Dials for sound, light, movement, smell. Every dial is spiking into the red. In under half a second, an almond-shaped structure called the amygdala grabs the wheel. And what does it do with that much control? It floods your system with a stress signal, and it effectively starves the part of your brain that makes sentences. That part has a name, the prefrontal cortex. It sits right behind your forehead, and it's the reason you can hold a conversation, plan a joke, remember a name mid-sentence. The amygdala treats it like a luxury item during an emergency, so it cuts the power. Your words don't disappear because you're stuck. They disappear because your brain just rerouted its own electricity somewhere else. Where does it send it instead? Straight to your muscles, straight to your lungs, straight to systems built for one job: survive the next 10 seconds. Language can wait. Your body can't. Think about the last time this happened. A crowded elevator, a group chat blowing up while the television talked over everyone. Ever notice your eyes go blank without deciding to? That's your visual system narrowing its input, one less dial spiking in the control room. Why would a crowded kitchen trigger a response built for danger? One proposed explanation: some nervous systems are simply built to notice more. In 2018, researcher Ruth Karpinski and her colleagues studied a group of people with sharp cognitive processing. She found their nervous systems reacted to ordinary input: a scratchy shirt tag, a flickering light, a stranger's raised voice, the way a body reacts to a real threat.
This
She called
theory
it the
connects the brain and
hyperbrain,
body. It
hyperbody
explains how they
theory.
work.
A brain that takes in more also reacts to more. It doesn't file a party under mildly annoying. It files it under unknown and overwhelming, and it responds accordingly. What does that look like in two different nervous systems? One files the blender, the laughter, the overlapping voices under background noise. The other gets everything at full volume, nothing filtered out. Karpinski's data suggests some brains simply don't come with a volume knob. But sensitivity alone doesn't explain the shutdown. So what actually pulls the trigger on the brake itself? That's where a second scientist comes in. In 1998, neuroscientist Bruce McEwen published a paper that reframed what stress costs the body. What is the real price of staying wired for too long? He called it allostatic load. Every stress response, he found, comes with a price tag. Cortisol floods the bloodstream, heart rate climbs. And if that flood never stops, the system meant to protect you wears it down instead. McEwen showed that chronic overstimulation doesn't just feel bad, it physically damages neural tissue over time, the same tissue you need for memory and language. So what does a brain do when the cost gets that high? One possibility: it starts sacrificing higher-order functions like language to lower the immediate demand. Silence isn't a failure, it's a circuit breaker, tripped on purpose to protect the wiring behind it. Your brain doesn't shut down because it's weak. It shuts down because it decided talking mattered less than surviving. Where did that circuit breaker actually come from? Not a kitchen, not a conference room, a clearing, 60,000 years ago at dusk. A branch snaps somewhere in the dark. Every head in the group turns at once. Here's one way researchers interpret what your ancestors' nervous system was actually built for. Firelight flickers against a ring of faces. Somewhere past the tree line, something moves that shouldn't be moving. Nobody knows yet if it's wind, a deer, or a predator that's been watching the group for an hour. What's actually out there? The uncertainty itself is the danger. And uncertainty is exactly what a loud, crowded, unpredictable room recreates today, just with drywall instead of trees. What's the single worst thing a person could do in that clearing? Keep talking, keep making noise. Every extra sound is a flare fired into the dark, telling a predator where the soft, slow, talkative animal is standing. So evolution built a switch. The moment sensory input spikes, the switch flips. Voices drop, movement freezes, even breathing slows down. Not because anyone panics, because stillness is the only strategy in that clearing with a survival rate worth keeping. Did that switch ever get an update? It didn't know cities were coming. It didn't know about open plan offices, group chats, birthday parties with the music too loud. As far as your amygdala is concerned, a chaotic dinner party and a chaotic predator ambush produce the exact same sensory signature. Multiple fast sounds, multiple moving bodies. No clear threat to point at. Can your amygdala even tell the two apart? Its response is identical either way. Go quiet. Go still. Wait it out. Why does this always sting a little? You've probably called this a flaw. Maybe a coworker did it for you. Too sensitive, too withdrawn, bad at parties. But a switch this old wasn't built by your personality. It was built by every ancestor who survived long enough to have kids, because they went quiet at the right moment in the dark. Does that mean the shutdown always works perfectly today? Not exactly. Your ancestors' clearing had an exit, a tree to climb, a group to run toward. A modern kitchen doesn't. You can't out-freeze a birthday party the way you could out-freeze a predator, so the switch just holds you there, engine idling, waiting for a danger that was never going to arrive. So what do you call a brain that does this on purpose? Not a broken brain. A brilliant one, running software 800 generations too old for the room it's standing in. Think about the times you've gone silent at the wrong moment. The meeting where you had the answer and it never came out. The dinner where your voice refused to surface. That wasn't you failing the room. That was ancient circuitry doing its job, pointed at the wrong century. You can usually feel the moment it happens, once you know what to look for. A tightening behind the eyes. Words queuing up and then vanishing before they reach your mouth. A pull toward the nearest wall, the nearest exit, the nearest quiet corner. So what's happening in that pull? That's not embarrassment. That's your amygdala making a withdrawal from your prefrontal cortex power supply in real time without asking permission. And once you can name it, something shifts. You stop treating the silence as evidence against you. You start treating it as data. Your nervous system is telling you exactly how loud, how chaotic, how unpredictable a room has become, faster than your conscious mind ever could. A shutting down brain feels surprisingly familiar. A friend once described it as a phone at 1% battery, closing every app it can spare, just to keep the one call that matters from dropping. Your brain does the same math in a crowded room. It isn't picking apps at random, it's shutting down the most expensive one first, and conversation is one of the most expensive things a brain runs. What would it even look like to work with that switch instead of fighting it? Not forcing yourself to talk over the noise, not apologizing for stepping outside for 30 seconds of quiet, just recognizing the mechanism for what it is. A very old, very fast, literal-minded bodyguard, still doing the one job it was built for. The lights in that control room behind your forehead aren't broken. They're just powering different systems now. Because here's the thing that never changes. The room gets loud, the switch flips. Your voice goes first, and your body goes still exactly the way it was designed to, 600 centuries before anyone built a kitchen, a group chat, or a party that never should have had this many people in it. So the next time you get real quiet when it gets too loud, remember this. You're not defective. You're not antisocial. The world got louder. Your brain never stopped protecting you.